All right. So today we are going to figure out the differences and similarities between displacement and distance, describe another way, describe ratios, what they communicate, differences and similarities between velocity and speed, and calculate the average velocity for a trip, multiple parts. So read that question, press pause. Correct answer is B. Magnitude is the absolute value of whatever measurement we're going to take. So that should, you'll see that word throughout the rest of the year. Magnitude just means the absolute value. Forget the positive, negative sign. It actually makes your life easier. So rejoice when you see that word. Pause. All right. Correct answer is? Correct answer is B. So displacement is equal to final position minus initial position. Okay. So you ended up at the 10 and you started at the 40. Good with that? You ended up with a negative 30 yards displacement. Okay. Same scenario, but what is the distance now? Sums up when you have a guess. Talk to your neighbor.
If you're going negative 30 yards.
Correct answer is? Correct answer is A. Okay. So, all right. For this chapter and the next chapter, we are going to be focused on motion along one dimension. That means you're stuck on a number line. Okay. You can just go right and left, just like you're stuck, like going this way, that way, like that's all you got. Or we could go like up and down. It's one dimensional motion. Okay. So, how can we describe which way we're moving mathematically? Like, what is it that we discovered communicates direction? This is where you throw something out. Yep. What communicates direction? Nope. Good guesses though. Nope. Good guesses. Nope. Good guess. Nope. Good guess. Nope. Good guess. What? Okay. What does a vector have? Direction and magnitude. How does direction communicated though? That's what I'm digging for. Yes. Positive and negative. Positive and negative signs communicate direction. Does that make sense? Okay. So if I'm going this way, I've got a positive displacement on a number line. If I'm going this way, I've got a negative displacement on a number line. Okay. So is displacement a scalar or a vector? It is a vector. Why? Because a vector communicates Magnitude and direction. Okay? So can distance be negative? Can distance be negative? No, it's just the magnitude. Can displacement be negative? Yes. So do you see why in physics we prefer to focus on displacement rather than distance? There's more information. It's richer. There's more stuff communicated. Good with that? Okay. All right. Give this one a shot. Thumbs up when you have a guess. Have a conversation.
Would be B.
Please explain to me why it's sure.
Correct answer is? Correct answer is B. Okay. Displacement. What it cares about is where you ended up and where you started. Not really, doesn't really care about how you got there. Remember that? Same scenario, but what about the distance? Tell your neighbor. It's a rough combo. Yeah, that's rough. Okay, what do you say? Correct answer is E, 50 yards. Okay, distance does care the path you took. Going from here to here, back to here. See the difference? Another distinction. Okay. So, have you ever run the 400? Okay. One lap around the track. What's your displacement? 0? 0? I'm about to pass out. What are you saying? 0? Like, how do you say I have 0 displacement? Because you ended up where you started. Okay? You accomplished nothing. Now, you did burn calories. Distance was 400 meters. Distance, burning calories, that's a thing. Okay? But displacement, you didn't get anywhere. Does that make sense? It's a good plug for track right there. All right. So, real quick, here's a life uh, piece of advice. That's going to seem unrelated, then I'm going to bring it back to relating it real fast. When you start a new season in life, new academic year, different move, something happened, like when there's a new season, if there are changes that need to take place, do it right away. Do not wait. Because as days go on, the norm becomes more and more entrenched. Okay? Case in point, I did not assign seats to you. You picked these. But very, very soon, these are going to be your seats. Like it would bug you if someone sat in your seat. Right? Like no one's going to change. Like this is just human nature. Okay? If you are, so much of learning that takes place in this class happens in these conversations of talk to your neighbor. Okay? Things in your brain are formed, are strengthened, are exercised as you have conversations with people, whether they agree with you or disagree with you. This is like learning is taking place. Okay? Some people are like, this is stupid. I get the right answer all the time. You guys are just holding me back. Communicating your thoughts is a very employable skill. You can be the smartest person in the world, but if you can't communicate it, who cares? Does that make sense? So like this time where I'm devoting to talking to your neighbor is beneficial in a lot of different ways. If you find yourself in a seat that is not conducive for these conversations, change now before the norm gets more and more entrenched. Does that make sense? Like if you're sitting there just awkward, take this time to look around for other people who are looking around awkward and make a move. Like, like, if you like your seat, then be part of that neighborhood. I know that's awkward, but man, this would be a lot better to like break through this now than like sitting here the whole semester going, because we're doing a lot of talking to our neighbors. Okay. So, next question. I really like it a lot. Thumbs up when you have a guess. Have a conversation. Make sure you are communicating. Why?
Just like we made this. That was really
Yeah, I was saying.
yeah. Okay, did you like change settings? Like go one way, just go back. In the direction. I mean
That's better than the 800.
I agree with that.
I hate the 8 is the worst race.
You and Trent,
I did, yeah.
what did you run?
I started at 2 mile. They whittled me down to the 4x4 by the time I was a senior.
I love 4x4 as well.
Yeah. All right. Correct answer is D. Dangerous dinosaurs. Okay. So if you're moving this way in the negative direction, if you turn around, that breaks things. Okay. But if you're always moving in the positive, you're good to go. But here's the cool little secret. If I don't specify, if I don't tell you which way is the positive direction in a story problem, you can make the way they're moving the positive direction. And so long as they don't turn around in the scenario, distance and displacement are interchangeable. Does that make sense? Like a lot of people get hung up like, I don't know if it was distance or displacement. Well, if you make the way they're moving positive and they don't change direction, either one doesn't matter. You all right with that? Okay, but if they do change direction or they do go in the negative, then you need to make a distinction. Okay? So this slide here is training wheels. Okay, usually I won't do this. I'm going to give you a chance to write down stuff that you've learned. These slides have been a distinction between comparing and contrasting displacement and distance. So I want to highlight what you are writing down right now is your working definition. Rather than saying, hey, Google, what's the definition of displacement? You have an explanation or points or characteristics that you can relate to. Does this make sense? Like just getting a definition doesn't transpire into understanding. Using it allows you to learn what it is not. Okay? Okay. Here's some factoids. Clock reading. In geometry, when they introduced a point to you, what is the length, the dimension of a point? How long is a point in geometry? Nothing. It's just a point. It doesn't have length. Good at that? Clock reading. This is a point on a timeline. This is a point on a timeline. This is a moment or instant in time. It's a moment or instant in time. So as a clock, as a second hand goes around, how long is the second hand pointing at the 12 o'clock position? If it's not one of those, but just a moment, an instant, a clock reading. Does that make sense? Okay. Now, a time duration. This is a change in clock reading. So in a story problem, they're usually talking about a time duration. Like they ran for 2 hours, or they drove for whatever, or how long did you go driving? That's talking about a time duration. Okay. Rarely did you ever get in a clock reading unless like the classic math story problem, or like train leaves station A at 12:05 and reaches station B at 2:35. Okay, so those are obviously clock readings, but most of the time we're talking about, when we're talking about time and a problem, it's talking about time duration. Okay, factoid there. All right. Remember our conversation about 30 eggs and how many dozen? We're going to have another conversation that you're familiar with that's going to highlight something. Okay, so you go to the gas station, fill up 14.7 gallons of gas, costs you $58.40. So this ratio, when we take 58.4 divided by 14.7, we all can do this in our calculator. That's not hard, but what I care about, what I'm asking is, what does that number communicate? So just so we have something to, like, when you do it on your calculator, you get this. What does that communicate?
Gas price per gallon.
Okay, the gas price per gallon. I agree with that, but I'm going to push back on that just a little bit. We throw around this word per a lot. It's a math term, but I want to know, can you say that without saying per?
397 a gallon instead of saying A. So
Yeah. Yes.
the ratio of the amount of money instead for 1 gallon.
Good. That's what I'm going for. Okay. So check this out. Ready? We'll capitalize on that here in a second. Don't worry about trying to write that down. Just check this out. Okay. Look at your units. You've got dollars on top. You've got gallons on bottom. The answer is, when you put this on your calculator, that is how many dollars you get for every 1 gallon. Does that make sense? Okay. Now, this is what we see projected on all the signs around on gas station signs. How much gasoline, sorry, how much it's going to cost you for 1 gallon of gasoline. Okay. What would happen if I took that ratio and I flipped it? What would that communicate? So the answer, your calculator spits out that. What does that communicate? Without saying per? Yes, I agree. Okay. So you've got gallons over dollars. Okay. So this is how many gallons you can buy for every $1. You're seeing how that, okay? So here's where I'm trying to get to. Well, in general, whenever you have a ratio or you divide anything, what does that communicate? That communicates how much of the numerator there is for every 1 unit of the denominator. Okay, this is what you should write down. Ratio communicates how much of the numerator there is for every 1 unit of the denominator. All right, and this, you've done division. You're like since elementary school. But what I'm trying to get you to do is not just be able to like get an answer, but understand what that answer communicates. We're using math to describe situations in life. And you need to have a good working understanding of what it is your calculator is communicating when you hit equals or enter. Good with that? Okay. So, next question. Tell your neighbor. Okay. Correct answer is C. Now, you might have been able to figure that out by just association, like, oh, speed is measured in miles per hour. Velocity is kind of like speed. Meters per second follows that same pattern. Okay, it's true. Here's what I'm going to coach you. Okay, I'm going to make you memorize units. Okay, but here's the thing. You can figure out the units based upon just a couple primary, what I'm going to call primary colors of units. Okay, displacement is measured in what unit? You measure displacement or distance in meters. We're a metric system in science. Okay, over, what's the unit for time duration? Seconds. The unit for velocity is meters per second. This will always work. You can always figure out the unit by looking at the equation. Okay, so you've got some primary colors, and you can mix and match to make different colors. So like displacements in meters, time durations in seconds, masses in kilograms. Those are like your primary colors, and you can mix and match those and come up with a whole lot of different units. Good with that? One last question. Tell your neighbor. Correct answer is, for the sake of time, B. It moves 3 meters every second. So it goes 3 meters and then an additional 3, 6, an additional 3, 9. So every second you add 3 meters. Have a great weekend.